as you go through the chapter, okay? But I would take their chapter and I put it in notes, and then we're going to need to download the assignment. Oh, sorry. Let me do the right one here. Okay, so in the notes this week, the authors start talking about, you know, why RAM is essential in our area of the field. And as you know, the computer uses RAM for a lot of different things, especially when it works with applications. So we need RAM for applications. We need RAM for our OS. We need RAM for, you know, just even when you put your system on hibernation. Like if I close my laptop right now, right, it actually store a file, and then it would, you know, pull that file from RAM so that way it knows what I have open, what I have used, etc. So with RAM, it gives us a picture of what's happening in that system at that moment in time. So it is a vital source for digital evidence, and it is important how we collect this data, because if you use a certain tool, if you're not paying attention or be careful with it, you can actually modify the state of the machine. And that's really the touchy area with digital forensic. So the fundamentals with RAM, it talks about what we can get. So information about current state of your system, right before you shut down, okay? What processes was running, what kind of applications were using the resources, even from networking standpoint, right? Or we saw a little bit of this when we looked at the hard drive, your browser information. So RAM give you the current system state. Along with that, we can evaluate the impact of malware with RAM. So in a lot of ways, from networking all the way down to applications and our system, password encryption, copy paste clipboard information, we can pull that from RAM. And it gives us a snapshot of the running system right before it shuts down. So in the case where if you have to investigate and that computer was already off, right? What we can do is we can evaluate the data that exists in the RAM and see what application they were running and what they were doing right before. So here's some additional information about what could be contained in RAM. That's on page 1 of your notes. And let me open up my assignment so I could show you what we should be answering. So in the first question, okay, it asks you what type of information can be found in RAM when conducting the digital forensic investigation. So we can find information about the current system state, the running state of the system before it shuts down. We can find information about the running programs and the processes and the malware processes, possibly if it has malware. So in the case of ransomware, right, they can also pull that from RAM as well, even though in a lot of cases, ransomware will encrypt the hard drive, which contains your volume for your OS, your root volume. Okay, so we can find some of the information in RAM. In the network cases, we would find network connectivity information, so network connections of the host. And also if they're sharing files to their peers, like if they're using peer-to-peer file sharing feature, we will also find that. We can also find link to attackers, especially from the networking area. Now you know that network appliances they all have RAM storage from router to managed switch. And so we can pull some of that. Now, outside of the computing system, we can look at the network appliances as well, and the security appliances too. We can look at the user actions based on the processes on that system. So user actions. And then in the cases of passwords, files that they access, clipboard text, meaning that if they right click or do Control-C for copy and Control-V for paste, all of that, when they copy, clipboard is updated. So text that's being copied, and then encryption keys, and in some cases, if files were being decrypted, we would find some of that in RAM as well. So it's a long list of different type of information that we can acquire by analyzing RAM. And depending on the cases, we wanted to focus our scope more in the areas that would pertain to the case, right? In the case when if you're doing network forensic, then we can start looking at the network processes, the systems that's involved in the network or a certain segment of the network. If you're looking at a breach, you need to really identify where the unauthorized user is coming in from. So if we're not able to obtain this information otherwise using the networking tools, we can look at the storage in the appliances in our systems that are connected to really put together, right, maybe a timeline and the course of actions in based on that timeline for our investigation. Any questions? So later on in your note document and in the chapter, it will go over the type of tools that you would use to do this. So RAM, random access memory, this is volatile, right? Meaning that you need to supply power to the system in order to be able to have access to the data that's stored in RAM. And unlike hard drive, it's at a faster speed and it's using chipsets on the module, or we would call that a card or a RAM stick, right? And sometimes that could be incorporated with the microboards or the board of the system. So for example, if you're looking at smart TV or smart devices, it might not have its individual module for the RAM. It will be a set of chips that would be incorporated, right? That they were soldered on or built onto that board for storage. So when you're looking at smartphones, right, when you open up the smartphones, you would see that specific chips would be designed for the storage. Now, in the case of Android technology, we would have additional storage that would be more on the permanent, non-volatile side, like your SD, right? It would retain data when you remove the power, compared to RAM, internal RAM, on a smartphone that needs power supply in order to retain. So now, so, you know, every OS would have some form of ways to utilize specific files in order to capture, right, processes and actions of the user, right, tabs that will be open on browser, applications, things like that. So, and it would use the permanent storage, which is could be SD or drives, like hard drives, and then it would update the RAM and it would go back and forth that way. Okay, so in random access memory for RAM, you would have two main types, would be your static RAM, which is your SRAM, and your dynamic RAM, your DRAM. The computer memory that we see as in RAM module, like through your DDR4, DDR3, etc., that's more on the dynamic. So that will be your your SDRAM, okay, synchronous dynamic RAM. Now, static RAM, you would see that more in processor. That would be utilized as cache or some form of storage for processing. And it's much higher in speed and more expensive to produce. So your SRAM is more efficient and faster, and you will often see them in smaller size. We don't use SRAM for, you know, as in individual RAM module for your desktop or your laptop environment. So that will be incorporated with the processing. So CPU, you would find SRAM, and that would tie back to your cache memory or your cache size in your processor. In the DRAM, that will be cheaper to produce, and this is what you see as DDR2, 3, DDR1, DDR4, and on even at the level of your video graphic storage, your VDRAM. So right now, I think they're at DDR6, right? Transitioning from DDR5, and DDR5 is not available for module installation as RAM adapter, but DDR5 is incorporated for video. So it's definitely cheaper to produce, and that will be a lot more common when we're looking at investigating a computing system, especially when we're looking at what kind of applications the user was accessing prior to the system shutting down, or they might have leave the system running, so all of that is still in RAM. So in the next question, after question 1, we need to explain why forensic investigators should avoid disconnecting the system power when in an investigation. So because RAM is volatile, it needs power to maintain the data. So when we power off the system, we actually lose the volatile data when we disconnect that power line. Now, in many cases, you might find a dead system or a system that doesn't have any power, right? Because sometimes that they know, so they would shut down the system after they wipe the data from the hard drive. But you can still go back to the files for the OS, to the system files, to be able to pull some of that. Okay, because that was collected from the RAM and it updates it. So if you see a system that's running, right, when you show up to collect the data, you don't want to turn off that system. So that's what that question is implying. We want to leave the system running so we can actually gather what's happening in RAM for that system, the current state of that system. Okay. So here we state that data stored within RAM chip is considered volatile. Therefore, if we disconnect the power, we would lose the volatile data. So let's say that we see a laptop that's connecting to a financial institution that's processing an illegal transfer, right? And that they abandon that laptop, they escape the scene. Then we don't want to shut down that laptop. We want to be able to investigate what's happening and to be able to gather all the evidence that we need for that illegal transfer, for that fraud case. Okay. Any question? So in the next question, it asks you, what kind of RAM will you commonly find in digital investigation? And you would find SRAM or DRAM. Because these are the types that are commonly produced now. So in your case, right, like when you get experience, or if you're working as an intern, or when you after you get your certifications and you become a forensic examiner, you would likely find that you would see SRAM and DRAM. And there's evolution of these over time, of course, but they are still commonly used since they were first created. So we haven't transitioned that much, moving away from CPU storage or your computing storage for applications and processing. Okay. Any question? Okay. So in the different type of operating system, we mainly look at 32-bit and 64-bit. That kind of tell us the limitation in RAM storage. For 32-bit operating system for Microsoft, you're going to be limited to under 4 GB of RAM. And with that, what we can say is that the amount of data that's stored in the 32-bit operating system for Microsoft, that will be that much, less than 4 GB. Okay, I think it caps like right under 4, 3.94 something. Then with the later current operating system, like Windows 10, where it's 64-bit, you can have up to 120 GB of RAM. Microsoft documented that it would be more, but right now I think that, you know, the maximum amount of RAM that you can install or use in a system that's running 64-bit Microsoft OS is 128 GB. And that's a lot, right? We're looking at, you know, in a sense where if you're looking at even gaming system or powerful consumer PC, you would see that most of the time people are at 32 GB, at 64 GB, and then if you're looking at server operating system, that could go higher. So now, then we have to really prepare and see, right, the type of storage that we need to gather the data from either small or larger storage, right? So you have to be making sure that you have adequate storage to be able to copy all of that data over. Okay. So with addressing, an address is used to identify the location of that data in RAM. And so for the CPU, it would need to access the data possibly for executing, right, a specific code for application or for OS, for a different task. So what it would utilize is it would rely on the address, the memory address, to be able to identify where that data is physically stored. So that would be your physical address. Now, often that we would see memory dump issues with blue screen of death for Windows, right? And with the blue screen of death, you would see an error code and you would see the address, right, that's indicated for the memory dump. Okay. So when you're looking at the raw memory dump, we're really looking at the physical address or the offset of the memory dump. Okay. And that could span, right, depending on specific process and different things. So if you're looking at the physical address of a certain file, that could span over a group of addresses, okay? Now with the data that's stored in RAM, often that you would see it would use pages or page file. So that would be about 4 kilobytes in size. So we can see that each of these page would be 4 kilobytes. Okay. And when it uses page file like this, what it does is it uses a virtual addressing. So a way that the system can maximize the capability of storage is that instead of using RAM completely, it would use a hard drive, right, to store some file and then use that file to update RAM periodically, because we don't want to overflow, right, the volatile storage. We want to be able to use something that's temp and use that temp location to periodically update the RAM. Okay. So, and it doesn't really matter what kind of operating system that you use, whether it's Windows or Linux, you would see this mechanism that's implemented, right? So, okay, so the physical address pertain to the actual memory address for specific raw data, where we would also use the virtual addressing is a way that we would use pages, right, to allow system processes and read data, and that would update the RAM. Okay. So in the next question, it says, what type of memory address is used for memory dump? And what type of address is used for system processes? So your physical addresses are used for memory dump, and virtual addresses are used for system processes. So if we want to know what kind of processes we're running, then we can simply access the page file. Okay. Any question? And every application, when it runs, right, it would require a section of the storage RAM to be able to allocate for its own application component. And when you learn programming, it talks about this, right? Having to utilize location for variables, you know, container objects, etc. So in that sense, right, it would have offsets of addresses, okay? So therefore, with operating system, what we have is that's a software, right? So, and within that, it has different capability and sub applications for those capabilities. So you would see these things being incorporated, physical addresses and virtual addresses for the OS. Any question? Okay, so here it gives you a little bit more details about operating system accessing RAM. And so now we know that, you know, when we have people on the network, they have to have individual account, user account, and with that account, they are given a certain set of privileges to be able to access, you know, different areas of the system, okay, to have different control within the operating system. So the operating system would require RAM for privilege separation for the user. and whether that user belongs to a certain group membership, which ties back to what they're allowed or whether or not allowed. So now the system itself would have some kind of mode, system mode, kernel mode, and then also the trusted mode. When the user use the operating system, they're actually operating at the untrusted mode, or in Microsoft case, they call it the user mode. Okay. So when I'm opening applications, it's actually executing command. It tells the system, right? And we see this from the command prompt level, is when you open and close and, you know, move data, you're actually executing commands. So with that would incorporate the instructions for the operating system to do something. And within each command, that could be multi-processes. With the system call, this allows the operating system to access your resources. So whenever a user runs the application, it needs to make some form of request, right, for the resources. Okay, and this is being done in the kernel level. So with that, when the user accesses it from an untrusted mode or the user mode, it needs to move those requested into the area where the system can manage the resources and manage the request. So that would be considered system call. So it moves it to the trusted mode. Okay. And all operating system has a way to manage processes. So because you can have multiple programs running simultaneously, I can have 5 browsers that are open. I can, you know, watch a video and, you know, take notes at the same time. Right now we're doing things simultaneously. We're on Zoom, right? We're video conferencing, and so in such that the system needs to be able to manage the processes, and all your program code is executed in memory, right? All your application is executed in memory. Okay. And then it needs to be able to control the threads. So a process will have multiple threads, and these are just unit for the system resources. So that way the CPU can provide or respond to certain requests, and the system can respond to the CPU when it needs to, especially when we deal with input and output for application. So for example, when you run Microsoft Word, right, you have some form of input output. You have input in such that you type text, and then you have output in such that you see it on screen, so you know what you're typing. And with that, we would have separate threads, so that way it would incorporate that with the processes. So the operating system can manage the resources on how the CPU handles your input when you type your text, and handles the output when those text is encoded and shown on screen. So when we look at memory dump, and we're actually looking at the processes in that time window, the timestamp of the processes. And we're looking at the addresses that are pertaining to those processes, so that way we can tie back to how the code is ran, or for that particular application or for the process. Okay, any question? So the next question it asks you, it says, what should an investigator examine when analyzing memory dumps? We need to take a look at the processes that are being executed at the time of capture, and the data that's being stored within the RAM. In particular, we would look at the timestamp of those processes and the starting addresses that would relate to those processes, which help us identify the code of the process. Okay. So you can find this in detail on page 2 of your notes for question 5. Okay, and then they added additional information about RAM content that kind of go back to the earlier questions, right? The artifacts that we can pull from RAM, things like system configuration, command types, passwords, encryption keys, unencrypted data, IP addresses, internet history, chat conversations, emails, malware, and more. Those are just the general. Okay. And if you think about the processes that's happening for each of these area, right? Like for example, email, the user would have to log into email. So that would have some kind of stored password, right? And then to utilize the application to open the email, whether it's browser-based email or if I'm using Outlook, right? That would be a Microsoft applications or some other type of application for mail access and so forth. So we can identify the processes and the timestamp of those processes by looking at RAM. So now when we're looking at the sources of memory, what if the system has already been shut down for a long time? It's not running live. We cannot do any kind of live capture at the moment. Well, then we have to go back to some of the resources, right? When the system is powered down, in the operating system, it would store some form of hibernation file, okay? Like a user can put that onto hibernation to walk away from the system, or in the laptop sense, when you close the screen, right, that would activate the hibernation file. Okay. So hibernation is a process that powering down the computer while maintaining its current state. So it stores what is the state of that system, what kind of things that were still open, or what kind of, the connection the system had, etc. Okay. In Windows, it uses the hyperfill.sys file. And what happens here is it says that RAM is compressed and stored into the hyperfill.sys file. So the state is actually, it pulls that from RAM and then it puts it into the hyperfill.sys file. And this file goes onto the hard drive. Then the system would be, when it reactivated, when we open up the screen for the laptop again, or press a button on the keyboard to wake it up, what happens is it's going to take that file and it's going to put it back into RAM so it can it would go back to the state where the system was before it goes into hibernation. So that's one of the areas that you can look at when you're doing investigation. So going back to our question, in the next question it asks you, explain the purpose of hibernation file, hiberfil.sys. So we can simply state that RAM is compressed and stored onto that file, which then allows the system to power down. But when the system needs to be woken up, the content of that file is then be loaded back into RAM. Okay. Any question? And going away from this class, you're going to see the computing system in a different view, right? We would know a lot of the background, right, procedures and resources that, you know, normally the user wouldn't be aware of, because you have to be able to pay attention to these little details of what's happening in the course of action to really be able to get your evidence. So we would have to understand, you know, when the system goes into hibernation, when people are accessing application, what's really happening. Okay. Any question with number 6? And you can find the exact content on page 3 of your notes and also in the text. And here it talks about the laptop, like I mentioned, when you open and close your laptop screen. So when the system is repowered, when it receives the power again, right, the header file, the header of that file is zeroed out. Then it's going to be, so because it's a compressed file, it has to decompress it before it puts it back into RAM. Okay. So if you cannot do a live capture of the RAM, then you can take a look at the hibernation file for that system. And then next we're going to talk about page file. So paging is a way that we can store and retrieve data that's used by RAM using virtual memory, but it's stored on a permanent storage drive that's non-volatile, like hard drive. It is not as fast as RAM, however, it would allow the program to use the capacity of the physical memory. So it would swap out, right? And then use that space for other application, and therefore it just switch back and forth. So that way you don't need a huge amount of RAM. You can still operate with the minimum requirement, right? It'll just be slow where it has to keep swapping. So with the page file, it uses pages, and we talked about how it's 4 kilobytes. So it says that when using paging, the system will transfer the data in pages. And then it would typically at least request the data being used in memory. So when the request for the data is processed, it would place the data back into the physical memory. So it would temporarily store it into more of a permanent drive. And then when it gets the request from the system, then it would take that and it would load that back into the physical memory. And then it just keep going back and forth like that. So when we use a temporary storage like this, we call it virtual memory. And you can set this from a user standpoint, right? You can set this in your setting to have it, you know, to the max or however that could be allocated. Okay. So the operating system allow you to be able to interact with it that way. And then with crash dump, this is when you would get some kind of error or crashing in your system. And in Windows, it's blue screen of death. Okay. So what it does is it create a dump of memory to store the information for that state. Okay. So a lot of the times blue screen of death is caused by errors, usually with application or possibly with OS. Okay. Then what happens is it's gonna get rid of what was there just to make room for others, right? And then with that, you would lose the state for the time being. So you have to reboot and get it back to where it was. So you have different type of dump. You have complete dump, where the data is contained within the memory only. Where you have kernel memory dump, then those will be pages with the kernel mode. Okay, so for the next question, it's going to ask you about what is stored in the page file.sys. And in some cases, we would see that program data that exceeds the capacity of the physical memory. So for example, like I would have a very large set of data that would be more than what is allocated in RAM for that application. Then it's going to use the virtual memory to store those files, right? That will be in your hard drive or your root volume. Then it's going to pull that as the application, as the system would fulfill the request for that application. Okay. And the type of memory dump, we touch on complete memory dump. That will be data that's stored completely within the physical memory in your RAM. Kernel memory dump, this is stored in pages with the kernel mode. And then small dump files, this contain information about running processes like drivers, okay, at the time crash. So in the case where if we're investigating malware, likely that you will need to also examine small dump files outside of the others. Okay. Or if an attacker is causing your system to crash, right, we wanted to see information about the processes running before it crashed. Any questions about memory dump? So the resource you can refer to for the question 7 and 8 is page 3 in your notes for the page.sys and page file.sys and then your memory dump. That will bring you to page 4. So before it goes into capturing RAM, it talks about how you can look into your system hive. And this is the path. It actually updates this as well. We talked a little bit about registry last week, so that kind of tie back to the prior chapter. So to evaluate RAM or to analyze RAM, we would use third-party tool, okay? Because when we test RAM in the system, that doesn't really, it just tests to see if it reads or writes, right? So for forensic, we would use other tool to look into the RAM. So before you start evaluating the RAM, when you capture it, there's some impact. Okay, as we mentioned that, you know, anything that you plug into the system, it changes its state. Anything that you run, an application that you run on the system, that might have an overwrite or it changes the system. So based on the scientific work group of digital evidence, volatile data can be modified. Okay, here are some of the things. Application used to collect data in memory will overwrite some content. So keep that in mind and make sure we document that. With the tools to obtain larger or the files that's pertaining to it, some data will also overwrite. When you plug in a USB, because you need that to be able to capture the data, to have a location where you can store it, right? When the system load that USB device, it needs to run the driver and it needs to put that into memory. So it does have alteration to the RAM state. When you load USB, it also changes registry, right? Because it's a hardware, and when you plug that in, it also changes, so it updates registry. So keep that in mind. And when you're running the application to collect the data on memory, it will show in, sorry, it should be in MRUs. So it might likely show up with the list of the evidence that you can acquire. It might mix some of that in, so make sure that you understand that. Okay. So, but we rather capture the RAM and gain, right, more information than just ignore it. Okay, so we weight the risk with that. So now with this, it asks you, it says, in RAM analysis, what effect of using USB does, what is the effect of using a USB device in a system memory? So when you load it, the device driver will load that into the memory. So USB device driver will be loaded into memory, and the system will also load the driver into the registry. Then for number 10, it says, based on scientific work group on digital evidence, what should you consider when using applications to analyze volatile data in RAM? That it might overwrite some content in the memory, and that if it's a larger tool, it would also, the files of those tools will also overwrite the data, which cause contamination, right? But if we know the areas, the possible risks, we want to make sure that we look out for that. So it is a short chapter. A lot of this, the later part is screenshot of how to use some of the tools and where to get those tools. So, you know, a big chunk of it is presented in like 3 pages in the textbook. Any question with this? Okay. So what do we need when we want to capture data in the RAM, on the RAM? You're gonna need a USB device, and in the notes it mentioned that you should always try to have USB device that's larger than 16 gigabyte. You need to have administrator or the highest privilege, and you need to have access to the system. Would be physical access, of course. Okay, so those are the 3 main things that we need, and then additionally we're going to need software tool, and we'll talk about that. So to capture RAM, we would need some kind of storage device, usually USB. Access to the system, and the highest system privilege. So when you run these tools that we're going to talk about, you have to run them as administrator if the system is logged on as another user. Okay. Any question? Okay, so the USB and the application's concern and risk is located on page 4 of your notes. And then the capturing requirement, the 3 things, it's also on page 4 right below that. Okay. So here are some of the tools. You can find Dump It, right? You can use Dump It to be able to analyze RAM content. And here it says that no options are asked by the end user. This tool is fast, small, and portable, but it leaves at least one significant form of footprint on the RAM. So it does modify the RAM as you use it. And it's a command line base. So in a Windows environment, we would use command prompt. So you have to run as administrator, right, in CMD. And then you would navigate to, you would point to the USB device that would contain the executable. And then you would execute it. So if, let's say, if it's dumpit.exe, then I would open up command prompt and I would do dumpit.exe. But I have to do cd, change directory to the folder where it contains it. Okay. And it would look something like this. So after you have it launched, it's going to ask you, it's going to present to you the physical memory space, the amount in bytes. And if it asks you, you want yes or no to continue, and then you would have to press Y to proceed. And then once it goes, it's does its thing, and then it's going to be able to capture the data from the RAM for you. Okay. Now, another proprietary tool that you see is Ftk Imager. This has the graphical user interface where you can click the buttons and or menus to select. So again, we would use a thumb drive or a USB drive. We would plug that into the target system itself. And then you're going to browse, right? So if File Explorer does not open up, then you can press Windows and E to open up your File Explorer. And then you're going to click on the file and select capture memory. There, your memory capture screen, it's going to look like this. Then you have to fill in, right? You can browse to the location for your destination where you want to store that. So I would point back to a drive where I would store all of that file. Okay. Give it a name, and then you can select different type of files. Okay, like pagefile.sys. And then once you're done, you click capture memory. And then it will show a progress like this. So this is the Ftk Imager Lite. So the last three are going to be open source. So you got the bulk extractor. I previously used a bulk extractor. It's great with disk image. You can pull a lot with disk image and files. So bulk extractor. So it's going to ignore the file system structure, but it's going to look at things as data sets. Okay. So what you can do is it can scan the target disk or storage, and it can extract what would be useful or what it deems to be useful, and you can specify it. So you would need to run it. Of course, you have to download it, and you can run it. So the first thing it's going to do is going to present you with the options list. And then you would have to select the bulk extractor output. Then you're going to click Run Bulk Extractor to analyze. So it's going to look like this. Okay. And then after that, you can select. So if you have an image, you can do image. If you have a raw device, like when we plug stuff into another target system, we would select raw device, or we can find it from a file directory. Then here, what you can do is you can specify how you want it to scan. And then also what kind of file and the size of the file you want it to look for. In my opinion, I found it to be more user-friendly than some of the other open source tools. So, especially when you're seeking files. Okay. And we can specify offsets on a certain processing. So once you have selected the areas that you need, then you just click submit. And then it will begin the process. Okay. So it would look something like this. The cool part about this is that it organizes the files for you, and I like it that way because I think that, you know, it's a lot easier to look at this than just the text in console. So that's one of the benefit of using this tool. But you do get stuff like URLs and what if you specify that in your seek criteria. And then on the right side, this is, you know, a logical way for it to present you the memory dump and the address that's correlated. Okay, the offset. Any question? So that's your bulk extractor. And then the other two is Volatility and Volix. So this one, Volix, is also graphical user interface. It has capability where you can select and input text, but it also has a CLI option. And Volatility is mainly used for incident response and malware analysis. So when you deal with like hit of malware or trying to analyze malware that's impacting your system or network, that's a good tool to use. So you can find the link there. Okay. And it's able to analyze multiple OS. Some of the, even the proprietary tools, some of the proprietary tools only for like certain OS. So, and some open source ones that way as well. So this is the screenshot that the author offered for Volix. Okay. It's pretty simple. So you would use this with John the Ripper or, you know, some kind of virus analysis tool. So it works best with another tool in a company, another tool. Okay. So here what they're saying is that for the malware, you know, you can use something like Virus Total, or if you wanted to use John the Ripper for crypting and decryption and stuff like that, you can also use that. Okay, so it works best with another tool. So image file allows us to calculate the checksum and compare to see the integrity and the difference in that. Because if the malware is impacting the system, you would have different sum for specific file. And then it has a report mechanism. Okay. And this is good for incident response because you can build the questionnaire with it. You can interview people based on the incident and so forth. Okay. So as it is limited with capability, it should be used in certain area with another tool. So for the next question, the tools that we can use is called Dump It. That's the first one that's shown with the command prompt. FTK, using the memory capture under FTK Image Light. And then you can use bulk extractor, Volix, or Volatility, or all, or combine. Okay. So if you have a dead device, see if you can analyze the RAM in that dead device. Or even a system that's still running, something that you don't use anymore. A smartphone, you know. So, and with mobile forensic is, you know, you can use also mobile suites for forensic. They have different tools now for mobile appliances and devices. So that's pretty cool too. So that way you can explore and brush up your skills. Okay. Do you have any question for me? Okay, so that conclude the assignments that we need to do. Do you need any questions or any things to be addressed?
I think I'm good. Just quiz time.
Okay. All right. So just a reminder, if you didn't take the quiz last week, make sure you take the quiz. I do open it for a little bit of time. Let me see. I think your extra credit is still open. Okay. So it's about, I think it's going to be closed tonight. And then I would have, there are only 3 people that participated, but the highest person that score on this will get a prize. And then you can also get the extra credit if you participate. Okay. So once it's closed, I will get the result and then I will send the prize out to the individual that scored the highest. So if you haven't attempted, you can do that, and then you just need to submit your score for 20 points, and I will add those points to the area that you need. Okay. Now the book, if you have time, read it over. It has really great resources. And then catch up on anything that you miss. Okay. All right. That's it from me tonight.